In this problem, we are given this set of equations, and we need to find voltage 1 and voltage 2. Looking at these, the first thing I'm going to see is that this is a voltage over ohms. That means if we divide them, we are going to get amps. We're going to use this formula, voltage is equal to current times resistance, and then rewrite it to see that our voltage over resistance is equal to our current. So this is just going to be 7.5 amps. Now the next thing I'm going to want to do is combine everything inside of our parentheses that we can so that we can make this problem a little bit easier on us. So I'm going to combine those and I'm going to combine these together. So rewriting this, we're going to have V1 and then in parentheses we'll have a 9 over 8 ohms. And then for the rest of the equation, nothing else changes. Nothing changes with our V1, but for our V2, we're going to add all of these together, and then we're going to have a 24 on the denominator, because that is the most common denominator between the three. We're going to have a 3 plus 2 plus 6, or we can rewrite this as 11, and this is equal to 7.5 amps. We can see that there is a common similarity between these two, and that is this 1/8 and this 1/8 right here. So what I'm going to do is actually cancel out the V1, that way we can find V2. To do this, I'm going to multiply this bottom part by a 9. If we do this, we're going to have a 9 and 99 up top for our V1 and V2, and then we're going to have a 67.5 amps for our equals on the right. Now I'm going to be able to cancel out this V1 because we have a V1 times 9 over 8 ohms, and this is a negative V1 times 9 over 8 ohms. From here, all I'm going to do is add our V2s together. That means I'm going to have to multiply this top part by 3 over 3 to get the denominators to be the same. And then we are left with this. So from here, I'm just going to add to our 67.5 amps the 4.5 amps. That means we're going to get 72 amps over here. And this is going to be equal to a V2 with a 96 divided by 24. If we have a 96 divided by 24, this is equivalent to 4. And we can't forget about the ohms on the bottom. So this is actually not just a 4, it is a 4 over ohms. We're going to multiply both sides by a ohms over 4. That way it cancels out on this left side. And then in here, we're going to have our 4 over ohms. And if we do this, we can see that we have a 4 on the bottom, and then we have our resistor on the top. And then we know from this equation right here, resistance times current, that the resistance times current is equal to our voltage. So we'll just divide 72 by 4, and then we get 18. So V2 is equal to 18 volts. That is the answer for V2. Now we're just going to plug in our V2 right here into somewhere where we have V1. This looks like an optimal spot right here, so I'm going to go back in here before we did any of the changes. So our equation is going to look like this. And then for V2, I'm going to be substituting in our 18 volts. So we have 18 volts right here. And if we divide this out, since we have volts over resistance, we know that we're going to get current because of this equation right here. Volts over resistance is equal to current, and that is measured in amps. So after we do this, we're going to get a 2.25 here, and it's a negative. After we do this, we're going to get a negative 2.25 amps. We're just going to add this over onto this side. So we're going to get 4.5 plus 2.25. And so we have that our V1, 9 over 8 ohms, is equal to 6.75 amps. Now all we have to do is multiply both sides by 8 ohms over 9. And then we know that our resistance times current is equal to voltage. So after we do this, we're going to get that our V1 is equal to 6 volts. And that is how you complete this problem. In your God, Peacock, I don't use Peacock. Unsubscribe. I cannot unsubscribe. I'm gonna just get rid of all this. Boop, 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 boop. Okay, cool. Alright,